Today, let's have a look at the Desmos we did last week. Which of the following has the most kinetic energy when moving at 5 meters per second? Well, kinetic energy depends on mass and velocity. Since the velocity is the same, the one with the bigger mass or the bigger weight will have the bigger kinetic energy. So, in this case, the wiffle ball. Which of the following has the least potential energy if they are at the top of the same hill? Well, potential energy depends on mass and it also depends on height. If they're at the top of the same hill, they're at the same height, so the one with the least mass, the bicycle, has the least potential energy. Which airplane would have the least kinetic energy on the runway? Well, assuming all the airplanes have the same mass, we look at velocity, and the one with the least velocity, number 1, will have the least kinetic energy. A rock rolls down a steep hill. The rock rolls at 5 meters per second and weighs 20 kilograms. What's the kinetic energy of the rock if Ke equals 1/2 mv squared? Well, we have the mass m, which is 20 kilograms, and we have the velocity v, which is 5 meters per second. So all we do is plug into our equation and solve. Half of 20 is 10, and the velocity squared, or 5 squared, is 25. So 10 times 25 will give us 250. Select all that apply. What could this be a graph of? Notice how on this graph, as the independent variable on our x-axis goes up, the dependent variable y also goes up. So we need to know which of these factors actually directly depends on the independent variable given. Does potential energy depend on mass? Yes. Does kinetic energy depend on mass? Once again, yes. Does potential energy depend directly on height? Yes. Does kinetic energy depend on height? No. Does potential energy depend on speed? No. Does kinetic energy depend on speed? Yes. However, if we go back to the previous question, notice how the speed or velocity is squared. If you have an exponent for your variable, then that means it's not a straight line, it's a curve. So these are the only 3 correct answers. Next, we're going to look at this graph. Notice how this graph, as our independent variable is increased, nothing happens to our dependent variable, which means the two factors are not related. The two that we said were not related were kinetic energy and height, and potential energy versus speed. Now we have the curve, which we said is kinetic energy versus speed because of the formula. I hope this helps.